Today's lesson is 6.2, Law of Cosines. Now in 6.1 you worked with law of sines, which was pretty easy to do. Basically you were setting up proportions, but you can't always use law of sines. So today we're going to look at how to find other sides and angles of triangles when you can't use law of sines. Law of cosines works, say you have three sides, side, 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 or maybe a side and an angle in a side, and you're not able to use law of sines. We will use these two sets of formulas. The standard form is when you're looking for a side or sides, because you have a squared equals or b squared equals or c squared equals. So right here you're looking for a side, a, b, or c, and the alternate form or alternative form is when you're looking for an angle or angles, because you're looking for cosine of capital A, capital B, or capital C. So on your formula sheet or on your notes here, just keep in mind that you're going to use these formulas if you're looking for a side or sides, or you're going to use these formulas if you're looking for an angle or angles. So let's start off with an example. Well, number one, we need to find the three angles of this triangle. So we need to find angle A, angle B, and angle C. And obviously you can't use law of sines because you can't set up a proportion. You don't have any angles here. But if we had one of the angles, then we could use law of sines. Now, a suggestion here is, a hint is to start off finding the angle opposite the longest side. So we are going to find the biggest angle first. We're going to find the largest angle first, which will be the one across from the longest side, which means I want to find C first. Okay, so let's start off finding angle C. Now, if you'll look back at your formulas, that means I'm going to use this formula right here, cosine of C, because I'm finding an angle and I want to find angle C. So I'm going to do a squared plus b squared minus c squared over 2ab. And if you have your separate formula sheet, have it out handy so I don't have to flip back and forth to the formula here. Okay, so here we go. Excuse me. So I'm going to do cosine of angle C equals a squared, which is 8 squared, plus b squared, which is 14 squared, minus c squared, which is 19 squared. And all that is over 2 times a times b. 2 times 8 times 14. So I want to find angle C. I need to calculate all this. If I calculate all of this divided by all of that, I come out with approximately negative 0.4509. Now, to write it down on my paper, I rounded it, but I would like for you to just keep all of that in your calculator. Cosine of C. Now remember, when you're looking for an angle, you need to use your second button and make sure you're in degree mode. Put a little note here. Degree mode. Degree mode. Little star here, degree mode. So you need to go second cosine of your answer there, and that will tell you that angle C is approximately 116.8 degrees. So 116.8 degrees is angle C right here, 116.8 degrees. Alright, so from here you have some options. You can either continue with law of cosines, or based on what we learned in section 6.1, you can continue from here with law of sines, because look what you can do. You can put 19 over sine of this angle that we just found, and then you can set up a proportion to find one of the other angles. So I'm going to put another little note here. from here, you have choices. You can do whatever you want, but from here what I would do is I would use law of sines because I personally think law of sines is easier. So from here, use law of sines because I think it's easier, but that's up to you. If you want to continue with law of cosines, you can do that too. But I'm going to finish this with law of sines. So I'm going to do angle A. Doesn't really matter what order I do next, but I'm going to do angle A. So I'm going to do 19, which is side C, over sine of 116.8 degrees, that's a parentheses, equals, okay, now I have 8, but I don't know angle A. So I'm going to put 8 over sine of A. Okay, so let's cross multiply here. Well, think about what you did when you did law of sines. I'm going to kind of skip a step. Hopefully we're to that point where you can skip a step here. This is going to end up being sine of A is going to equal 8 times sine of 116.8 degrees divided by 19. Because you'll have to multiply these together and then divide by 19. And since you're looking for an angle, you're going to have to do second sine of whatever this answer is. And A is going to be approximately 22.08 degrees. 22.08 degrees. So there's A right there. 22.08 degrees. If you have two angles of a triangle to find the third one, do you really need to do trig? I don't think so. All you need to do is add the two angles that you have, subtract from 180, find the third angle. So add these two, subtract from 180, and the third angle would be 41.12 degrees. Okay, on example 2, we have a side, an angle, and a side. A side, an angle, and a side. So we're going to find all the other sides and angles, find the remaining angles and sides. So we need to find angle B and C. So I need to find angle B and angle C. And I also need to find side A. And if you sit here and try to do law of sines, you'll find that you do not have enough information here to set up your proportions. So you're going to have to try something else. You're going to have to try some other option. So in this case, I don't have enough information to find angle B or angle C if I don't have side A. But I can find side A, so I'm going to go use my formula to find side A. So here's my formula to find side A. It would be A squared equals B squared plus C squared minus 2BC times cosine of angle A. So that's the formula that I'm going to use because I'm finding little a, so I'm going to start off with the A squared equals formula. Okay, so let's fill in what we have and see what we get. So A squared equals B squared is going to be 15 squared plus C squared will be 10 squared minus 2 times B is 15 times C is 10 times cosine of angle A, and angle A is 115, so 115. Alright, and that's what A squared equals. So let's finish up here. A squared equals, if you'll calculate all of this, well let's go through one more step here. Let's see, this is 225 plus 100 minus 300 times cosine of 115. Okay, so A squared equals, now if you'll calculate all of that, that comes out to be, I probably should do a little approximately, those are little squigglies there. A squared is approximately 451.79. Okay, so if you have a little square root, or I kind of gave my answer to my question away, a squared, how do you get rid of the exponent there? I need to take the square root of both sides. Right, I got to take the square root of both sides. So A is going to be approximately 21.26. So that's 21.26, and we're dealing with centimeters here, so this is centimeters. 21.26 centimeters. I probably should have done that on the first. Oh, we were dealing with degrees. Okay, I was looking back to see on the first problem it was degrees. I thought I left off my measurements there. Okay, so if side A is 21.26 centimeters right here, side A, now I need to find angle B and angle C. Okay, from here, pick your choice. Now, if you're doing this by yourself, how do you want to approach it? How do you want to finish? Personally, I am going to use law of sines just because I can and I like it better, because I have this side over this angle, and then I could put this side over angle B, or I could put this side over angle C. Doesn't really matter, but I do have side A over angle A, so I'm going to start off with that. I'm going to put side A over sine of angle A equals. Do I want to find B or C first? Doesn't matter. I'm going to find B. So I'm going to put side B over sine of angle B. Okay, so I'm going to have sine of angle B. Sine of angle B is going to equal whatever 15 times this. Going to multiply these together. 15 times sine of 115, and I'm going to have to divide that by 21.26. 21.26. Okay, I'm going to write over this way, because if I write down here it might get knocked off. Alright, remember, if you're finding an angle, you have to hit the second button. So you're going to go second sine of your answer being whatever this is. Okay, your answer being whatever this is. So how many degrees is that? That's going to be approximately 39.75 degrees for B. It's supposed to be a 3. 39.75 degrees. Okay, that's angle B right here. 39.75 degrees. Okay, find the third angle. You have 115 degrees plus 39.75 degrees. Add those two. Subtract from 180. That leaves you with 25.25 degrees for your third angle. And that is example 2. Moving on to example 3. In a softball game, a batter hits the ball to center field. The center fielder then throws the ball to third base as shown. The distance from the center fielder to home plate is 240 feet, and that's already shown on here. The distance between the bases is 60 feet. Okay, so right here you have 60 feet, and for those of you that aren't familiar with softball or baseball, that means here's home plate right here. Okay, this is home. This is 60. This is first base right here. This is 60. This is second right here. This is another 60. This is third. And this is another 60, and this gets you back to home. Okay, how far did the center fielder throw the ball? All right, here's the center fielder right here. The center fielder caught the ball, and the center fielder threw the ball right here. Threw the ball to third. Okay, how far did the center fielder throw the ball? So what we have is we have a side, angle, and a side. Now what we probably want to do, let me clear these off here. Okay, we have a side, an angle, and a side. We probably want to label our triangle with A's, B's, and C's so we can use our formulas. So let's label this. Let's label home A. The center field here, we're going to label that as B. Whoops. And that's our B. And third base, we're going to let that be C, just so that we can use the A's, B's, and C's in our formula. So if home is A, then across from home is going to be our little a. Across from C is going to be our little c. And across from B is going to be our little b. Okay, we're trying to find how far the center fielder threw the ball. So the center fielder threw the ball from center field to third base. This is what we're looking for right here. So we need to find A. Okay, we're finding A. We're finding this distance right here. We're finding this right here. So here's our formula. We need to find A squared equals B squared plus C squared minus 2AB cosine of A. Okay, let's see if we have enough information here. Excuse me. Do we know B? Yes, it's 60. Do we know C? Yes, it's 240. Do we know angle A? Yes, it's 45. So let's fill in everything. A squared equals 60 squared plus 240 squared minus 2 times 60 times 240 times cosine of, that's supposed to be a 4, sorry about that, 45 degrees. A squared equals, if I square these two numbers and add them together, that's 61,200 minus, if I multiply these together, that's 28,800 cosine of 45. So A squared equals, if I calculate all this, multiply all that, or not multiply, I guess I'm multiplying these and subtracting it from that. That is approximately, let's see, I'm going to round here, 40,835.3247. Now, I would prefer that you keep all that in your calculator, okay? Don't round. Only do rounding purposes for writing it down on your paper, but keep all that in your calculator and then take the square root of your answer. And so A is approximately, the center fielder threw the ball approximately 202.08 feet. And that's how number 3 works. On number 4, you've worked with bearing a little bit. So I'll read through this one and we'll talk about the bearing on this problem. A ship travels 40 miles due east. So here we go. The ship started at point A. It went 40 miles due east. Okay. And then it changes directions. Change directions. When the ship has traveled 30 miles at this heading, that just means that it's new direction. So look, it went 40 miles east and then it turned directions and now it's going 30 miles at this new direction. It's 56 miles from where it started, point of departure, and now it's 56 miles from where it started. Describe the bearing from point B to point C in the figure. So I want to know the bearing from point B to point C. I'll try to describe this the best I can what the bearing means. It's kind of about like sense of direction, like are you going west, northwest, or southeast? You know, how many degrees, oops, get rid of that. It's like how many degrees off, okay, like how many degrees off from in this case, due north, okay, or vertical. All right, so this boat didn't go straight north. It didn't go straight north at a 90-degree angle. It turned, it's going north, but it's also going east. It's going north, but it's also going east. So what we want to know is in here, I want to know what this angle is in here. Instead of it going north exactly, instead of it going straight north, it's going northeast. So we're going to find this whole angle, and then I'm going to subtract 90 from it so I can find just this part to find out how far off from due north are they going, because they didn't go straight 90 degrees, they veered off a little bit from going north. So I hope that helps explain the bearing just a little bit, and that's how we're going to approach this one. So what we're going to start off doing is finding angle B right in here. That's what we need to find first. So let's see what information we have here. Can we do law of sines? Can't really do law of sines because all I know are all three sides. Okay, I only have side, side, and side, but I can find angle B. Okay, so to find angle B, and I'm going to have to come down here where I have more room to write all this, I'm going to do cosine of angle B, and I'm going to use a squared plus c squared minus b squared over 2ac. That's my formula. So cosine of b equals 30 squared plus 40 squared. Well, let me come up here. I probably should have done this first for you. Here's angle B, so here's little side B. Here's angle C, so here's little side C. That's already labeled. Oh, that's already on there. Oops, sorry. Okay, that's already on there. Little b, little a, little c. It was already on there. Okay. 30 squared plus 40 squared minus 50 squared. 56 squared over 2 times 30 times 40. Okay, cosine of b is going to equal whatever all this turns out to be. I didn't divide it all the way out at this point. I just did 636 over 2400, but you need to find cosine, you need to do second cosine of this answer. So second cosine of your answer is 105.37 degrees. Okay, remember that means that's this whole angle. But you want to know the bearing. Remember, the bearing is how far off from north. So we're going to subtract the 90 degrees because this would be going straight north. So they veered off in a 15.37 degrees northeast direction. So I'm going to write it up here because hopefully this isn't cutting off on the screen. 15.37 degrees in the northeast direction. If you're checking it in your book, they write it different sometimes. They do north 15.37 degrees east. I don't really care how you write it. I actually write it as, northeast. So it's just 15.37 degrees northeast. And they write it north of east. So either way, just wanted you to know your book writes it kind of funny. Okay, we are ready for the last one. Yay! Heron's formula. This looks long and complicated, but it's not at all. It's super easy. Given any triangle with side lengths of A, B, and C, the area of the given triangle is, you can find the area using this formula. So you take the square root of s times s minus a times s minus b times s minus c. And of course, a, b, and c are your sides. But s is a plus b plus c divided by 2, which means s is half of the perimeter. Okay, that's what s is. S is half the perimeter. So you need to find half the perimeter, and then you can go plug it in the formula. So down here, we got one last example, and then we are done. Find the area of the triangle having side lengths of 43, 53, and 72. So the first thing we need to do is find our s, and that's half the perimeter. So let's add them all up. 43 plus 53 plus 72. I need to add them all up and take a half. Okay, half the perimeter. We're not doing the average. You don't divide by 3. You're just taking a half of it. So that will be 84. That's our s. So let's fill in our formula here. Area. Big square root sign. N for our s is 84. And then in 3 sets of parentheses, I'm going to do 84 minus each of our sides. And our sides were 43, 53, and 72. And all I have to do is go through there and calculate that. And that's the area of my triangle. So the area of a triangle for this situation, for this particular triangle, is approximately 1,131.89, and since that's meters, it's meters squared. And that is it. That is all for section 6.2, Law of Cosines.